Hello everybody. So right now we're going to go over velocity and acceleration and speed. So the gist for everything is these four different equations over here. We have this one over here, but this is just a variation of this guy over here. Um, but it's these four equations that are going to give you either a simplistic physics time, or it's going to make your life very difficult if you know them forwards and backwards. So you just must be able to play with these different equations and understand that you're always given at least three different variables, right? You're always given v final, or you're given v initial, or you're given acceleration, or you're given time, right? And you always have to think about what variable you're given and what variable you're missing, right? So for example, if you're told something is accelerated to either a final velocity, or maybe it's accelerated for a certain amount of time, or maybe it's accelerated for some distance, right? If you know if something is accelerated to a final velocity, is accelerated to a final time, or is accelerated to a distance, you're pretty much given that v initial is zero. You can pretty much just assume that v initial is zero. So if you're not given that initial velocity, and in the problem it states that it's something is accelerating to a final velocity, or something accelerated for a certain amount of time, or something accelerated for a certain distance, you can safely assume that initial velocity is zero. And I want to also speak about that. Physics is a lot of assumptions, right? This is the first science that you're going to hit where you have to use common sense to really understand the problem. And this is why a lot of people have a problem with physics, because they think that everything should follow a textbook formula, which it does, but you have to make sense of the problem before you can get the formula, right? So that's the thing, right? So if something isn't given to you with an initial velocity, it's safe to assume that it's zero, unless stated otherwise in the problem. For example, a car that was moving accelerated to a final velocity, right? At that point, right, the car is moving and then it accelerated, hence the initial velocity can't be zero since it was moving. Okay. But that's kind of the gist of it, right? So if something accelerated, to a certain speed, or accelerated for a certain distance or time, then it's gonna have an initial velocity of zero. Let's talk about free falling objects as well. So what is the acceleration due to gravity of something falling? It's gonna be 9.8 meters per second squared, right? What if this object is in a vacuum? What is its acceleration due to gravity? 9.8. What if this object, what falls faster in a vacuum? A 1 pound bag of leaves, or 1 pound bag of rocks? I'm going to give you 5 seconds to answer that. I hope you said both fall at the same time. Since they both weigh a pound and they both have the same acceleration due to gravity, 9.8 meters per second, they both fall at the same time. I know that's maybe hard to understand, but with the same weight, they are both falling at the same time, especially in a vacuum. So that's the thing, right? And if you're ever told that an object fell for, again, x distance, or for a certain amount of time, or it fell and it reached a final velocity of whatever, right? That initial velocity is going to be zero. Yes, I hope you said that as well. So the initial velocity is zero because you're dropping something, and then it becomes free falling. But when you drop, the second you drop something, if we drew like a diagram of something falling, right? Here's my shitty diagram. I apologize for the language. Here's my bad diagram, right? And here's the plane, right? And if you drop something, it's going to be right there. Then it's going to be there. 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 So after 1 second, it's going to be there. The same after a second, it's going to be at the same spot where you had it because it hasn't fallen. It's an object with no velocity, right? The initial velocity is 0, but after a second, it's going to be there. And after a second, it's there. So you see, it's going further and further down because of the constant pull of the acceleration due to gravity, right? It's going to start speeding up the object. So if you do a diagram of the velocity versus time of this object, it's going to be a straight line. Its velocity is going to be speeding up as time speeds up. So I hope this made sense. This is a very general explanation of the velocity, acceleration, and speed. If you have any questions, please leave it in the comments and let me know. Take care.